On July 16, 1945, in the U.S. state of New Mexico, the world's first nuclear weapons test took place, marking the beginning of the nuclear age. At the time, no one truly knew what the consequences of detonating the first atomic bomb might be. American physicist Enrico Fermi even voiced concerns that a nuclear explosion could ignite Earth's atmosphere. Still, the drive to create a more powerful weapon pushed fear and uncertainty into the background. The explosion occurred at 5:30 a.m., a massive fireball, reaching temperatures of around 16,000 degrees, instantly melted the desert sand at the test site, turning it into glass. The blinding flash was seen by eyewitnesses in populated areas up to 300 kilometers away. The 30-meter steel tower that held the atomic device was completely vaporized. Every heavy metal structure within 180 meters of the blast's epicenter was wiped out. To maintain absolute secrecy, American newspapers later reported that the explosion was caused by an accidental detonation of conventional munitions at a military airbase. After the American president received confirmation of the successful nuclear test, his stance during negotiations with the Soviet delegation at the Potsdam Conference became noticeably tougher. According to Winston Churchill's memoirs, Harry Truman became a completely different man after learning about the successful nuclear explosion. What the US president did not realize was that the Soviet Union was already fully engaged in its own program to develop weapons of mass destruction based on nuclear energy. In 1949, the Soviet Union conducted its first nuclear test at the Semipalatinsk test site. That day, the first Soviet atomic bomb was detonated, with a yield of 22 kilotons. However, few people know that the Soviet nuclear program could have taken a very different path, or might not have happened at all. The reason is that several assassination attempts were planned against Joseph Stalin, who personally oversaw the development of the atomic bomb. After the first test of a Soviet RDS-1 atomic bomb, an American reconnaissance aircraft collected air samples near the Kamchatka region. The surprise was enormous when U.S. intelligence analysts radioactive isotopes in those samples, clearly indicating that a nuclear explosion had taken place inside the Soviet Union. From that moment on, the confrontation between the United States and the Soviet Union for dominance in nuclear weapons began. The Soviet leadership now faced a new challenge, creating an anti-nuclear shield to protect its naval vessels. At that time, the United States was already conducting surface and underwater nuclear explosions to study the effects of nuclear blasts on ships and submarines. The existing Semipalatinsk test site was unsuitable for experiments in maritime conditions. As a result, a proposal was made to conduct nuclear tests on the Kola Peninsula, about 130 kilometers from Murmansk. However, Navy Commander-in-Chief Nikolai Kuznetsov strongly opposed this idea. The focus then shifted to Novaya Zemlya due to its sparse population and remote location far from major settlements. A bay in the Kyornaya Guba was selected as the future test site. The new proving ground received the codename Special Construction 700. At the same time, intensive work was underway on an ultra-powerful nuclear torpedo, intended for use against enemy naval bases and even coastal cities. Academician Andrei Sakharov proposed using a nuclear torpedo with a yield of 100 megatons. Such an explosion, he argued, would generate massive waves capable of devastating coastal cities. However, the dimensions of this super heavy torpedo were enormous, about 23 meters long and weighing nearly 40 tons. As a result, the technical design was reconsidered. The torpedo size was reduced, a move strongly supported by Naval Command. This led to the creation of the T-5 nuclear torpedo. It was a straight-running steam gas torpedo with an inertial guidance system, powered by a thermal steam gas piston engine using an oxygen-alcohol mixture. The nuclear warhead for the T-5 was manufactured at the secret facility known as Artemis-16. Its first tests were conducted in October 1954 at the Semipalatinsk test site, and they ended in failure. The explosive did not trigger a nuclear chain reaction, contaminating the test area with radioactive plutonium. Workers at the site were forced to manually collect the contaminated material. A year later, improved warheads were once again sent to Semipalatinsk for testing. Based on the results, the most suitable nuclear charge for the T-5 torpedo was finally selected. On September 21, 1955, the Soviet Union carried out its first underwater nuclear test. The average depth of the test area was about 35 meters, with a maximum depth of 70 meters. Target ships were positioned at distances ranging from 300 to 3,000 meters from the blast site. Submarines also took part in the test, operating at periscope depth. In addition to specialized measuring equipment, 100 dogs were placed aboard the ships. Using winches, the nuclear torpedo was lowered in a vertical position from a minesweeper to a depth of 12 meters. Right up until the moment of detonation, it remained suspended beneath the vessel. At 8 a.m. on September 21, 1955, the charge was detonated. According to eyewitness accounts, a gigantic column of water rose above the surface and seemed to freeze in midair. Moments later, thousands of tons of water came crashing down with a deafening roar. The test results showed that ships within a radius of 400 meters were sunk. At a distance of 500 meters, vessels suffered severe damage, while ships at 1,000 meters sustained only minor damage. The test was declared a success. The next test was scheduled for 1957. This new test was intended to take place under conditions as close to real combat as possible. A submarine was to attack surface ships using a torpedo equipped with a nuclear warhead. In April 1957, the Soviet Council of Ministers issued a classified decree authorizing nuclear tests at Novaya Zemlya to study the effects of underwater nuclear explosions on ships, submarines, and coastal structures. Target ships were arranged in the test area, all positioned broadside to the expected blast. The nuclear torpedo was loaded into the torpedo compartment of the Submarine S-144, a Project 613 boat. Before launching the nuclear-armed torpedo, 3 test shots were carried out using torpedoes of the same type, but without nuclear warheads. One of the 3 launches failed. This caused serious concern within the Soviet Navy leadership. During earlier T-5 torpedo trials, some torpedoes had shown instability in maintaining their running depth. Out of 15 torpedoes, 4 deviated sharply after traveling about half the distance, triggering the hydrostatic safety switch. This was followed by a command to detonate the warhead. Although these issues were believed to have been resolved after earlier tests, it became clear on the eve of the nuclear trial that the problem had not been fully eliminated. A failed launch of a nuclear torpedo could have led to catastrophic consequences. Even so, the test was not postponed. The Submarine S-144 entered the test area, and everyone froze in tense anticipation, their minds racing with anxious thoughts. At last, the submarine's commander, Captain First Rank Lazarev, gave the order to launch. The T-5 torpedo was fired from periscope depth. After traveling the prescribed distance, it detonated at a depth of 30 meters, sinking 2 destroyers, 2 submarines, and 2 minesweepers. According to the recollections of Ivan Boyev, a veteran of the so-called Special Risk Units, the test was observed from the shore. The personnel were lined up along a flat, rocky surface and told in advance that the explosion would be underwater and therefore safe, with no radiation risk. When the nuclear warhead detonated, an enormous column of water and steam shot into the sky, carrying fragments of the destroyed ships. Suddenly, a strange and intense glow appeared inside the water column, forcing many to shield their eyes. It lasted for several seconds, then faded away. A terrifying roar echoed across the entire bay. Moments later, those observing the test felt as if they were hit by a warm gust of wind. Then, in an instant, everything went silent. Everyone involved was required to sign non-disclosure agreements. According to Ivan Boyev, just 2 days later, his health deteriorated sharply. He experienced weakness, dizziness, and severe nosebleeds. Doctors could not understand what was happening to a young, physically strong man, and he was forbidden from telling them that he had taken part in an underwater nuclear test. In 1958, the T-5 torpedoes were officially accepted into service. They were produced in limited numbers for the Pacific Fleet and the Northern Fleet. Just 2 years later, production was discontinued. One of the main reasons was that the torpedoes had been developed under extreme time pressure, and the problems with their performance and reliability were never fully resolved. In addition, by that time, 533mm autonomous special nuclear warhead sections had begun entering service for standard torpedo models. These proved far more practical and ultimately replaced the T-5 torpedoes altogether.